this is simultaneous equations 5, and this time we have got a pair of simultaneous equations where you can see you haven't got a match, so the y coefficient is not the same, the x coefficient is not the same, and we can't easily make one into the other by, say, doubling or tripling or quadrupling. So we're going to have to go for a different strategy this time, and that is to make, we still need to make either the x's or the y's the same, and you could choose either. I'm going to go with the x's, and I'm going to do that by multiplying them by each other. So I'm going to times the top row by 5, and I'm going to times the bottom row by 3. In that way we're going to end up with 15x, and then we can carry on as normal. So I'm going to call that equation 1 and equation 2. So by timesing the top row by 5, I'm going to create equation 3. So that's going to be 15x, don't forget to times all of it by 5, and 10y and 115. And then the bottom row is going to be called equation 4 after I've timesed it by 3. So 5x's are 15x. You can see I've got my match now with the 15s. 3 times minus 5y is minus 15y, and 3 lots of 55 is 165. So now I've got my match, I can subtract as usual. So 15x take 15x is nothing. 10y minus 15y, don't forget the two negatives touching make a positive, so that's 25y. And 115 take 165 is minus 50. So if I now divide both sides by 25, I get y equals minus 2. So that's my solution for y. I'm now going to replace it back into one of the equations. It could be any of the 4. I'm going to go with equation 1. So 3x plus 2y equals 23. So if I now replace the y with a minus 2, I've got 3x, 2 lots of minus 2 and minus 4 equals 23. Now I've solved this. I'm going to add 4 to both sides. That gives me 3x equals 27. Divide both sides by 3, x equals 9. So my solutions were y equals minus 2 and x equals 9.